In this video tutorial here, I'll take you through the steps to configure a Modicon M340 PLC to communicate with an Altivar process drive using Modbus TCP, or otherwise known as Modbus over Ethernet. So the first thing I'll do is show you the network topology. We have a M340 PLC, and with this M340 I also have a NOE module that I'll be utilizing. It will have an IP address of 192.168.10.1. I will then connect that NOE module to our Altivar process 600 series, and I'll be using the embedded TCP Ethernet port, and that will have an IP address of 192.168.10.10. If you don't know how to give a Altivar process drive a fixed IP address, please watch our other video which details that. So I'll open up Unity Pro now and we'll configure the PLC. So the first thing I'll do is create a network that will then configure, and then once we've done that we'll assign that configured network to a physical Ethernet port, which is the NOE Ethernet port. So under the communication folder, I right click on the networks folder and select new network. I then select Ethernet and we'll give it a name, VSD network 1. Right, so we've created it, but now we have to configure it. So I'll right click and open. First thing I'm going to do is give it an IP address. So this is going to be the IP address of the NOE module, which is 192.168.10.1, and then we've got a subnet mask of 255.255.255. I'm also going to utilize I/O scanning because the Altivar process drive has this function. What it means is we can read and write to multiple variables within the I/O scanning device out of the process drive in one message packet, one message block. So with the process drive we have the ability to read 32 words and to write to 32 words in one packet, one message packet. So that really reduces the amount of communication, the amount of traffic on your network. So we'll set that up now from the I/O scanning tab. So this table here is where we configure all of the I/O scanning devices on our network, but in our case we've only have the one, which is our Altivar process with 192.168.10.10. We leave the unit ID at 255 and slave syntax is index. I leave the rest as is. The only thing I'm going to change are the lengths of our reads and writes. So first our read length will be 2. So I'll be the first read will be the status word of the drive. It'll tell us if the drive's ready, running, or faulted. And the second word is our speed feedback. I'll be writing to 2 words. The first one is a command word, so that's forward, reverse, and we can also assign a bit to do fault reset. And the second word is our speed set point. Once we've done that, we have to allocate internal memory words within the PLC to the variables that we're reading and writing to. So if we look at the read reference first, it's going to start at memory word 0 and finish at memory word 1. And then if we look at the write reference, obviously we can't use memory word 0 again. So to make it easier, I'll start at 10 and finish at 11. Once I close that, I'm asked to accept the modifications. I just say yes. Right, so we've configured the network. Now we have to assign it to a physical Ethernet port, and like I said before, I'll be using the NOE module. It's only got one port on it, so we only have the one option for channel 0. it's Ethernet TCP IP, and here we assign our configured network VSD network 1, which is this one here. Once we've done that, we can close it and it'll ask to validate the modifications and say yes. And now I'm going to use the DTM browser within Unity. If you're used to SoMove, our configuration software for drives, you'll notice that it's very similar in look and feel. So we'll open it up now. What I'll do is Tools, and then DTM Browser, and then I'll right click on the host PC and I'll add. So I'm going to select Modbus TCP communication because I want to configure the VSD through Unity Pro, through the DTM browser, using Modbus TCP because my laptop is connected to the same Ethernet network that the drive and the PLC are on, so that's how I'll be communicating to it. If I had a USB to serial cable and I was connected to the serial port of the drive, then I would select Modbus serial communication. But in this example, I'll be using Modbus TCP. So I then add the DTM, and I'm going to call it TestBench VSD. And I'll make sure that the protocol information, it's Modbus over TCP, and then go OK. Right, now we need to add the VSD to the DTM browser. So I right click and select add, and it's a 600 series drive that we're connecting to, and I'm going to call it VSD1, and I'll make sure again that that's Modbus over TCP that we're connecting to. And I go OK. It'll add the device to the to our manager, but you'll see that the IP address isn't correct. So when we do try to log on to the drive and configure it, it will eventually fail because we're looking at the wrong IP address. So all we need to do is go back to our DTM manager that I've called TestBench VSD, right click and select open, go to our address table, and here you can see VSD1 and the incorrect IP address. And now I'm just going to change that to 192.168.10.10. Apply that and then go OK, and now you can see the IP address has changed. So now hopefully if I've configured the drive IP address correctly and I've set everything up correctly here, I should be able to right click on our device and connect, and hopefully shortly a warning prompt will come up. There you go, and I just tick that I've read the warning and then go OK. And now I'm going to open it, and we're connected. So I go to the parameters list tab, and the first thing I'll do is make sure that the IO scanner table that I described previously is configured the same way as I want it to be in the PLC. So I'm using the Modbus TCP port, the embedded Modbus TCP. So I'm going to expand on that, then select protocol and drive profiles. Here you can see our 32 words in and 32 words out. When I say in and out, I'm always referring from the point of view of the PLC. So it's 32 words into the PLC, as in monitoring words, and 32 words out of the PLC, so control words. So if we look at our inputs first, we'll see the first word is ETA, which is the status word. So that's our our feedback to say what the drive state is. Is it ready? Is it running? Is it faulted? And our second word is the actual speed value, so the speed feedback calculation from the VSD. And in this case, DriveCom, that means it's in RPM. If we look at our output, our first word is command register. So that's the register or the word we use to control the drive. So that's this is how we tell it to run, to stop. We can also assign a bit in this word to do a fault reset and many other things. And our second word is our speed set point, and again it's DriveCom, so that's in RPM. What I want to do, however, is use Hertz instead of RPM. So I'll just show you. We select the variable that we want to change, right click, and then select modify. And instead of RFRD, I want RFR. So I'm going to search for RFR. It finds RFRD first, and the second one it finds its motor frequency. I'll just double click on that, and then you see it. And I'm going to do the same for our speed set point as well. So again, I right click, select modify, and instead of LFRD, I just want LFR, and there it is there. And I apply the changes. Okay, PLC is not connected and running, that's good. You must note, if you're making changes, you have to stop the PLC first, or else these changes may not take effect. And you also have to apply the changes again, or else they won't take effect. The next thing I'll do is tell the drive that its command to run is going to come via comms, via the embedded Ethernet Modbus TCP port, and that its speed reference is also going to come from the same location. So to do that, I'm going to go to complete settings, command and reference. And firstly, I'm going to change the control mode configuration from combined channel mode to I/O profile. Combined and separate channel means you must adhere to what's known as a CIA 402 state chart to control the drive. It can be very cumbersome, and it can be quite hard to code your PLC to adhere to that state chart. So I prefer to use I/O mode, and what that does is the bits in the command word are like virtual digital inputs. So bit 0 as an example is forward, and in 2-wire control all I have to do is keep that bit high and the VSD will run forward. As soon as I make that bit go 0, the drive stops. So that's the first thing I do. The second thing I do is tell the drive that my speed reference is not going to be from analog input 1 anymore. It's going to be from our embedded Ethernet. Always make sure that you hit the enter button and that you see the modified pencil symbol appear. Just like assigning embedded Ethernet for our speed reference, I have to do the same for our command. So I change from terminal block to Ethernet, enter, and then I apply the changes and press OK. So if I've done everything correctly, I should be able to build the project, load it into the PLC, connect to the PLC and monitor the words and manipulate the output words and watch the VSD run at a speed defined by us. So I'm going to build it first. Hopefully I don't see any errors. No, that's good. Okay. So I will now connect to the PLC, and I'm going to transfer the project to the PLC and run it afterwards. Okay, so now the PLC is running. If I just put that over here. I'll just create an animation table so we can manipulate and monitor words. So the first word I'll do is memory word 0, which is our status word. The second memory word is our speed feedback, which at the moment should be 0. Memory word 11 is our command word, and memory word 10 it should be is our command word, and memory word 11 is our speed set point. So I've got the HMI of the drive live streaming at the moment. What I'll do is I'll change the format of our command word to binary, and I'll just extend it. So as I was saying, bit 0 of the command word is to run forwards. So if I make that go high, you can see that the VSD is now run at 0 Hertz. That's because our speed reference is 0. So if I'm to change that to say 10 Hertz, we should see it go up to 10 Hertz. Now I need to put 100 in the value because the units are 0.1 Hertz. And now you can see we're accelerating and we're running now at 10 Hertz. So here's our speed feedback, and that's matching our speed set point. And what you can do is change it to binary, and obviously all of these bits represent a certain state of the drive, and you can look that up in our Excel spreadsheet to understand what they all mean. So I can stop the drive now, and you can see it's decelerating, and now it's ready. What I can also do, which I should have done before, was assign a bit to the for fault reset. So I'll do that now. So parameters list, complete settings, and then error warning handling, expand on that, and then fault reset. And at the moment logic input 4 is our fault reset, but I want to change that to say bit 4 of the command word. So I select CMD4, press enter, apply that, and then go OK. So what I can do now is create a fault on the drive. Once it's finished, So I'll just show a fault on the drive by the simplest way is probably just to stop the PLC from communicating. And we don't seem to have a fault. Yep, there you go. Just took a while. So now I can run the PLC again. And now I can go to bit 4, make that go high. And you can see that we reset the fault. Take that back to 0. And we can run it again. So it's pretty simple, pretty quick to set a drive up, get it operating. Obviously, this isn't how you would normally drive or control a VSD via comms. This is just to purely show you how quick and easy it is to get it into this state.